Hi everybody, my name's Tim Pulaski with TriMech, and today we're going to get to know SOLIDWORKS Electrical. So in the world of electrical design, there's a lot of softwares out there that can draft a schematic. But there are very, very few that can actually automate the process of documenting the schematic drawings and producing things like bills of materials and wire run lists, net lists, and things of that manner. So one of the big advantages electrical or SOLIDWORKS Electrical brings to the table is its ability to automatically capture that time-consuming process of generating bills of materials and other associated documentation to give you a more robust design overall. So what we're going to look at today is how to draft up a basic circuit in SOLIDWORKS Electrical just to show you the ins and outs of the software. We're also going to explore a shared parts library because in addition to being a drafting tool, SOLIDWORKS Electrical is also a collaborative tool that allows multiple users to work on the same project at the same time. So they'll have access to the same library. And then finally, we'll define a harness assembly and show you some of the ins and outs of working with that part of the software. So let's go ahead and take a look. So here we are in SOLIDWORKS Electrical Schematic, which is a 2D drafting software totally independent from SOLIDWORKS itself. So it does not require a license of SOLIDWORKS to actually run. What this is a drafting software that allows me to create schematics like this, but also manage these schematic drawings in a project browser over here on the left. This browser is really nice because it allows me to organize all the drawings associated with a project, along with including links to associated documentation like product spec sheets. So what we're going to do today is we're effectively going to replicate this circuit that we see here to drive a three-phase motor. So to do that, I could very well just do a Control-C, Control-V to copy-paste, but that wouldn't really make for a very interesting demonstration. So we're going to draft this thing up manually. To do that, I'm going to come up here to my upper left-hand corner, and we're going to draw multiple wires at the same time. And one of the great things about SOLIDWORKS Electrical is that it's designed as an electrical software from the ground up. So what this means for me as the designer is all the tools are related to electrical design first, and they include some real nice functionality such as automatically spacing wires and inverting phase that's specifically related to electrical design. But in addition to that, one of my favorite aspects of the software is the fact that as I draw wires, it automatically captures properties of what I'm drawing. So you can see over here on the right, these aren't just lines on paper. They actually have properties such as gauge, jacket color, and even manufacturer name and part number. This is all going to add up later on because I can collect this data just by virtue of me drawing this on the page and format it into things like bills of materials and wire run lists later on, as we'll see. So now that I've got my wires on the page, let's go ahead and duplicate this motor here from scratch. I'm going to browse into my symbol library and grab a symbol to represent this motor. Now out of the box, SOLIDWORKS Electrical gives you access to about 2,500 or so ANSI and IEC standard symbols, but they're all customizable as well and organized by classification. So you can either take one of these symbols and tweak it to suit your own needs, or you can import your own. We're going to grab this three-phase motor symbol and insert it right along with the one already in the project. When I do so, you can see it's automatically going to increment the tag of this component to the next available. All right, so I've got 4 motors in here. It's going to jump up to M5. And we can add some additional information about this motor, such as its physical location in the project. This will help me find it later on. Additionally, if I know what the manufacturer part number is that goes along with this motor, I can assign it at this time by searching into another shared database of part numbers and part references. So the great thing about this is I can filter by manufacturer name, and such as like a Leroy Somer motor here, and grab the part number that I'm interested in. SOLIDWORKS Electrical, what they give you is an online repository of part numbers totaling something like I think it's about 4.5 million now, manufacturer specified electrical components. So you can download these and populate your own libraries with these part numbers and then assign them to your projects like this. So when I do so, what it does is it not only assigns the part number, but it pulls information from the part reference and assigns it to the symbol itself. Things like pin terminals or pin labels, as well as associated information coming from the motor itself. So not only that, but I can go ahead and insert symbols from a shortcut menu as well. If I have favorite symbols that I use all the time, I can come over here to my symbols browser, double click on them here, and insert them very quickly. Right? It still automatically increments the tag, and I can save part information along with the symbols so that it automatically defaults to a commonly used one. Copy paste still works, Control C, Control V, but there's a really interesting aspect to it that I like to review. So when I copy and paste a symbol, not only does it copy and paste the symbol's geometry, but it also brings along the part reference and automatically increments the tag. For things like terminal strips, they're very easy to draw just by drawing a line across a set of wires. Pick an orientation for that terminal. And then here what I want to do is I want to add these four terminals onto an existing terminal strip. So what I'll do is I'll just search through my project for other terminal strips that I may have used, grab it from the list, and you'll see that it automatically bumps the mark of the next tag to 17 to be in line with the 16 that are already in this strip. We'll say OK, and it adds those terminals for us. Now, I don't really want to run wires directly out to this motor. I'd rather run a multi-conductor cable. So what I'll do is I'll replace these wires with a multi-conductor cable by just right-clicking on them. In here, I can assign an existing cable that I've assigned to the project to these wires, effectively replacing them in the project design. So I'll just take the wires, replace them with cable conductors, and what that does is it'll replace the conductors on the schematic sheet with different labels, but it also replaces their properties and adopts the properties of the cable conductor and not the wires. Okay, so we've just seen how easy it is to draft a circuit in SOLIDWORKS Electrical, but what about reusing content? Very, very commonly in cases such as power distribution, we're going to be reusing information from page to page or from project to project. So what SOLIDWORKS Electrical also allows us to do is easily capture information and save it into our shared library, thereby making that information immediately available to a lot of users to reuse over and over again. Let's take a look. So I've just finished up the design of this circuit. Let's go ahead and add in some power to drive a PLC later on in my design. To do this, I'm going to come over to a different part of my project where I've already detailed this circuit. Just a little transformer as well as a circuit breaker to protect the whole circuit. So what I'm going to do to reuse this is I could copy and paste it, but that's kind of a pain because I'll have to jump from page to paste it wherever it goes. So what I'll do instead is save it into my library as something called a macro. To do this, I just have to drag select the circuit that I want to save and then click and drag it into my library. Over here I can give it a name and some other properties, but if I just say OK, it becomes immediately available to both me and other users of the software to use in this project or many others. So if I pop back to the drawing that I was on before, I can just double click on this as if it were a symbol and bring it in. And when I do so, it'll ask me what I want to do with the contents of the macro, but most of the time I can just click Finish and it'll automatically bump the tags of all the components as well as maintain the components' references like part numbers. Right, this makes it really, really easy to standardize on a set of library content that we can use over and over again, saving us a lot of time. Now, we're running out of room on this page, so what I'd also like to do is connect these wires to the PLC drawing that I've got over here. So to do this, what I'm going to use is something called an origin destination arrow, or more commonly referred to as an off-page reference. So these are actually pretty neat. They're very, very easy to add. You just turn on this separate window and connect one wire from one page to the next. And what it's going to do for us is it's automatically going to add in an arrow with the correct page designation and row. And you can customize this to be whatever you'd like, but the process remains the same. So when I do this, not only is it going to connect the pages together, but it actually makes it very, very easy for me to navigate the drawing. If I go down here to these off-page references and double-click on them, what it lets me do is jump from page to page to see exactly where that connects. This is really useful when you're troubleshooting a schematic because it lets you jump to the relevant page without having to actually follow that reference and find what page it is. It's just a double-click away. What's also really helpful is if you export these to PDFs, this holds true as well. In PDFs, these are saved as hyperlinks. So we've got some customers right now that have actually standardized on using those PDFs and tablets to help troubleshoot in the field. So this is actually pretty cool. What a lot of our customers are actually doing is they're using this functionality to effectively replace big printouts of schematic sheets for troubleshooting purposes and instead going to a more condensed tablet form where they're electronically including the PDFs and providing the PDFs to their technicians. So the great thing about that is you can more easily keep those drawings up to date, and they're way, way easier to navigate if you have these big complex projects. So now that we've connected all these pages together, what we're going to do is we're going to go ahead and number all of our wires. Now, in many cases, people are doing this manually, one by one, and that becomes a very, very monumental task to manage as the design evolves over time. But with SOLIDWORKS Electrical, it's very easy. All I have to do is come up here, and with the push of a button, I can number every new wire that I've added to my project while retaining all the old number designations. So you can see across the entirety of the project, I've now got unique wire numbers for every single wire that I've introduced, with the added benefit of being able to customize how those wires get labeled. So for example, these three-phase circuits, for those wire sets, I want them to be preceded by L1, L2, L3, and then a common number. But with something like DC wires on maybe my PLCs, I just want a flat numbering system that's based on the page on which those wires reside. So there's a lot of flexibility available to you within SOLIDWORKS Electrical, while also automating these very, very time-consuming and repetitive tasks. So another major facet of electrical design for a lot of users is harness documentation. So let's take a look at how SOLIDWORKS Electrical can handle that and how that differs a little bit from overall schematic design. So what we have here is a harness design that we're just finishing up, and I've got one more connector that I need to add. So SOLIDWORKS Electrical actually has a specialized tool for inserting connectors called the Dynamic Connector Wizard, which allows me to generate connectors from something like the housing of a 10-pin Molex connector. So this is just a rectangular 10-pin connector that I'll insert into my design, and we'll give this a tag, so I'll line that up with the PCB tagging structure. So that's going to be P37. And what it allows me to do is insert a select number of pins from that connector. All right? So if I really did want to break this up, if this was a big, like a 50-pin mil-spec connector, I can break it up from page to page. But over here, I'm just going to drop all of them in at once. All right? From here, I'll clean up the reference designator from the lower pins because we don't really need to see that for all of those particular pins. From here, I'll go ahead and connect this in with the rest of my design. So once we've inserted the symbol for the connector, we can actually go ahead and flesh this out a little bit more by modifying the parts that are assigned to it, because connectors are not just composed of the housing, they also have crimp terminals or wire ferrules or back shells associated with them. So what I'll do is I'll just add to this list by searching for auxiliary components in my library. So what I can do now is I can go ahead and add things like crimp terminals that match the number of actually used pins. So I'm only going to use about 6 pins in this connector, so we'll add 6 of those. I can add back shells if necessary and other associated components, but in this case just the crimps will do. So we'll say select and OK, and that's not really going to modify anything on my schematic, but it will have an impact later on when I run a bill of materials. So now we'll just finish up the design by connecting this back in to the rest of the schematic. You'll see as I draw these wires, even though I'm drawing with a single wire type, it's going to match the wire style of the connected wires. Now up here, what I can also do, if I wanted to change the direction in which these are attaching, I can right-click on, well actually we'll just multi-select each one of these, and we're going to replace the style to make them commonly sourced from the other PCB. Right-click and edit that connection path, and you'll get a nice graphical interface over here on the left that allows me to easily select the direction that I want, say common to the left. That'll change all of these at once and give me a nice graphical representation to keep track of that connection. To complete the harness design, all I have to do is drag select all the components that are going to be in that harness, right-click on any one of them, and we're going to add those to a harness. And you'll see over here it's going to collect all of the items that I've selected and allow me to add those to either an existing harness or to a new harness. Right? So these are all going to be associated to harness H1. So when I select that, I can review the harness that I've just created. And you can see within here, all of the wires and components, back shells and connectors get added to the harness itself. So later on, we can run a bill of materials to keep track of all the information within there. So we've just finished documenting this design by reusing some circuit information through the use of macros and by numbering all of our wires automatically. So let's go ahead and see how we can now produce associated documentation like bills of materials and wire run lists using some of those tools in SOLIDWORKS Electrical. So as we've been drafting this design, what the software's been doing is collecting all of the properties of the wires and components that we've drafted, and we can collate and combine this information through the use of something called reports. Reports are these templates that allow us to generate things like bills of materials, PLC I/O lists, list of all the cables in my project, very quickly and easily just by pulling in all the properties that we've designed over the course of drafting these schematics. So you can see here in the bill of materials, it's picked up every part number that we've assigned to every component in this project, and all the associated tags, the quantity, and manufacturer. Same thing for PLC I/O lists and cable lists. If we wanted to add a new report to this, I'll just come up and say Add, and let's add a wire list or a run list to our design. By clicking on this report here, you can see that it's going to list out the origin and destination of every single wire along with its gauge and its associated length. If I wanted to modify one of these reports, it's very, very easy. I'll just click on the properties, and we're going to adjust, say, the column layout in the same way that we may do something like Excel. I can just pick and choose and click and drag and drop the columns themselves, or I can right-click on the header bar and turn off columns that I'm not going to use. So in this case, we don't need to see reference, but we do want to see wire number, the manufacturer name, and part number. When I say OK, it adds those fields. I can then say Apply, and it's going to adjust the report that's actually generated. So this is something that's just really very time-consuming for a lot of people to produce, and it's very, very manual to keep track of all this information as the design evolves over time. Once we have this report and we're done with the project, I can export this right out to Excel if that's the format I prefer, or what I can do is in the project, right-click on a folder and say Draw Reports here, and it'll automatically generate report drawings for every report that I've assigned to this project. So we're getting our bills of materials, our PLC I/O lists, our cable lists. All of those are going to be generated and produced within this folder structure. To review, I can double-click on them, and you can see it's just going to combine all that information and give us a really, really professional-looking drawing set. So hopefully this has given you a good overview of what SOLIDWORKS Electrical is capable of and some of the benefits it can provide to you and your business. If you have any questions beyond what we've seen here today, please feel free to reach out to me at trimec.com. So once again, I've been Tim Pulaski, and thank you very much for watching.